Well, greetings, mathletes, and welcome back. So today's topic is going to be absolute value equations. And so we need to talk a little bit about what the absolute value does first, and then we'll put them into equations and see how they play out. So having said that, let's talk about the absolute value here. So the absolute value of something is sometimes it's called its magnitude. But what it really is how far away the number is from zero, represented as a positive number. So if I'm looking at 2, right? The distance from 2 is 2 units. So what that means is the absolute value of 2 is equal to 2, because it's 2 units. If I go to the other side, to negative 2, well, how far is that from 0? It's also 2 units. Right? So the absolute value of negative 2 is also 2. So notice what just happened here. So it doesn't matter whether it's 2 or negative 2, the absolute value always comes out to the positive value. So really what it is, it's like a little positive filter. It only spits out the positive value of what you're working on. And really in that way, it's a lot like Oprah, right? Makes everything positive. It's the Oprah of functions. Okay, so having seen that, just looking at a couple of these things then, just as quick examples, because this isn't the part we're going to spend the time on. You know, if I had the absolute value of 9, that comes out to 9. The absolute value of negative 10 would come out to positive 10. Now, this is the one that gets people. If I have something like 6 minus 2, right? There's a feeling that you need to make that minus a plus. Because that's what absolute values should do, right? They make everything positive. It only makes the last thing you do positive. So here, there's still operations in here. You have to compute this first. So 6 minus 2 is 4. So this is the same thing as the absolute value of 4. So it comes out to positive 4. Incidentally, it would work the other way around. If it was 2 minus 6 and I took the absolute value, that would be negative 4, so that's the absolute value of negative 4, which is still positive 4. Right? So you're not changing the signs of operations, right? What you're doing is you're changing changing the sign, changing it to positive, particularly the sign of the last computed number that you can get out of an absolute value. Okay, so let's go ahead and get rid of this. Now, if I'm going to take a look at an actual equation, let's just start with the simplest form of an equation. The absolute value of x is equal to 2. Okay, so what that means is we're looking for a value for x that makes this a true statement. So looking at this, we just want to ask ourselves, what could be in the place of x that would give me a positive 2? And I think most people jump straight to the answer 2, right? The absolute value of 2 is equal to 2. So that's good. So that means x could equal 2. But isn't also the absolute value of negative 2 equal to 2? Which means that x could also be negative 2. So you actually, with these absolute values, most of them you get 2 answers from. There's actually 3 cases. You can get 2 answers, 1 answer, or 0 answers. Those are your 3 cases. So let's just kind of expand this a little bit. So if I look at the absolute value of x is equal to 9, what that means is x could be positive 9 or negative 9. Now, when you list things with a comma like that, it's understood to be an or statement, right? Now, there's another way to write this, although, and I'm just going to kind of introduce it here. Your book does not use this notation yet. So, it may you may not see it anywhere in the book, but it does pop up later on this semester. So one of the ways you can compact this down a little bit, let's just do that. There we go. You can write both answers this way. Now, at this point, that would probably be something you do in your notes, because the homework program isn't going to allow you to use that plus minus because there isn't one. You end up having to list them out separately. But for the sake of expedience, it's a lot easier to write the plus or minus, right? That represents x equals 9, x equals negative 9. It represents both of those solutions at the same time, just by putting the plus then the minus. Okay, now if I have something like, I don't know, the absolute value of x equals 0. So if I have an absolute value equal to 0, that's kind of interesting too. Let's see. There's no positive or negative 0, right? Not like the other numbers. You have positive negative 1, positive negative 2. There's only one 0. There's no positive or negative to it. So it doesn't matter if I throw a plus or minus on it. There's only one solution here. X equals 0. That's it. There's one equation. So you have one solution here. Now, the last case that we would want to look at here, if I have the absolute value of x is equal to a negative number, and you have to watch out for these because these things sneak in there and you just don't notice them because you start getting into your pattern of solving and you just forget about the fact that you have a negative there, and you start doing things by reflex. Let's just think about what this actually means. So first of all, the absolute value will only spit out numbers that are 0, right? We just saw that. We can get an absolute value of 0, right? Absolute value of 0 is equal to 0. So I can put a 0 in there, or I can get a 0 out of an absolute value. I can get positive numbers out of absolute values. I cannot get negative numbers out of absolute values. This thing can only assume positive values, which means that if I set it equal to a negative, there isn't a solution. There's no value of x that when I take its absolute value, I will get a negative 2. There just isn't one. So what we say here is that there is no solution. Right? That's it. So as soon as you have an absolute value by itself equal to a negative number, that's your case for no solution. And I know what you're thinking. Is there a case for all real numbers? Because those things usually go together. So you should, when you get one, you should start thinking about whether or not you're going to get the other. And as far as equations go, there aren't any. Right? At least not in the case we're going to be looking at. But yeah, generally when it's equations, you don't get any all real number type solutions. However, you do get all real numbers when we start dealing with absolute values with inequalities. Okay, so we'll start playing with that here before too long, but not today. Okay, so these are the things we have to watch out for. So if I have an absolute value equal to a positive, I get solutions, right? I get two solutions. If I have an absolute value equal to 0, I get one solution. And if I have an absolute value equal to a negative, it's no solution, right? There's no solutions to that. Right, so those are things to know. If it's equal to a positive, you get two solutions. If it's equal to a 0, you get one solution. And if it's equal to a negative, you get 0 solutions. So let's go ahead and see how this plays out when we start making things a little bit more, well, you know the word, interesting. Let's make it a little more interesting. Okay, so we saw that what we got before, when I set this equal to a number, basically what I got was two equations out of it. This gave me two solutions, x is equal to 5 or x is equal to negative 5. Okay, this is going to be the general thing we do each time we start an absolute value equation. We get the absolute value by itself on one side, and then we split it into two equations. Now notice the absolute value is gone once we split it. That's important. If you leave it on there, it's a brand new equation, and you're going to get two solutions from there. So you want them to be gone. The way you split up an absolute, the way you get rid of an absolute value is to split it into two equations. So if I have something like this, the absolute value of x plus 3 is equal to 5. I still split it up. I take what's inside the absolute value, and this x plus 3, if it's equal to positive 5, then when I take its absolute value, I get positive 5. But also, this x plus 3, if it was equal to negative 5, I would get 5 when I take its absolute value as well. So I get two equations, one for the case where it's equal to 5 and one for the case where it's equal to negative 5. And what I do is I just solve both of these. Oops, I got a little typo here. Is it a typo when you're writing it with a, I don't know. That's semantics. Okay, so these are our equations, and basically we solve them. Once you have the absolute value gone, each equation solves exactly like every other equation we've done. So the real only difference that we have here is the ability to split into two equations. So if I subtract 3 from both sides, I get x is equal to 2. And here, if I subtract 3 from both sides, I get x is equal to negative 8. So I have two solutions. I have x is equal to 2 or negative 8. And notice they're separated by a comma. We can check each of these answers just by plugging them in for x in the original equation. When you're checking your answer, you always go back to the original equation because that's the place you haven't made mistakes yet, right? Because you're checking to see if you made a mistake. If I plug it in down here, what if my mistake was going from the first step to the second step? Right? Then I wouldn't catch my mistake. I would just be reinforcing it. So you always want to go back to the original problem. So let's try each of these solutions. Let's try it when, we're done with that one. When x is equal to 2. Let's see what happens. So that if I replace x with 2, this would be 2 plus 3. So the absolute value of 2 plus 3 is equal to 5. And then let's see here. So that's the absolute value of 5 is equal to 5. Definitely works. Check. Now we try negative 8. So negative 8 plus 3, the absolute value of negative 8 plus 3, we want it to be equal to 5. Let's see if it's true. So let's see. Negative 8 plus 3 is negative 5. And the absolute value of negative 5 is 5. So that one's a check also. So you can always go back and check these things. The big trick is getting it to split into two equations and understanding how that works. So you want to have the absolute value, before you split it, you want to have the absolute value by itself on one side and some expression without an absolute value on the other side. As soon as you get it to that point, you split it. The left-hand side stays identical but doesn't have an absolute value. The right-hand side assumes positive and negative values as you go. Okay, so let's go ahead and clear this, and we'll try another one here. So let's see if you can use what we've learned so far to walk through this one on your own. Let's just see what you get. So let's see here. We got 2x minus 5 is equal to, let's make it equal to 15. Okay, so go ahead and pause here and see what you get. And then go ahead and play it again, and we'll walk through the solution. Okay, so I'm assuming you paused it. And let's make sure we've satisfied the condition here. We have the absolute value by itself on one side, right, over here. And then I have a number on the other side. Those are the things that I wanted. I don't want anything else other than the absolute value on one side and a number on the other. And I have that taken care of. So I'm going to split this absolute value. So I'm going to take the 2x minus 5, set it equal to 15, and then take the 2x minus 5 and set it equal to negative 15. And we're going to see what we get. We're just going to solve each of these equations. So I'll add 5 to both sides here. So that gives me 2x is equal to 20. And then I divide by 2, and that gives me x is equal to 10. So that's one solution. And then over here, if I add 5 to both sides, that's a negative this time. So that gives me 2x is equal to negative 10. And then if I divide by 2, I get x is equal to negative 5. And so really the question is, does this work? Right? These are our two answers. We are saying that the two answers are 10 and negative 15. So let's see if they work when we plug them in here. So let's see here. So I got 2 times 10 minus 5. Well, that's going to be 20 minus 5. And that's the absolute value of 15, which is equal to 15. Right? So that one checks. Now we need to check the other one. And we're saying we got negative 15 here. So 2 times negative 15 minus 5. Oops, absolute value. Where'd I go here? Wow, I can't believe I just did that. I caught my own mistake. Let's just go ahead and finish this. Okay, so this gives me negative 30 minus 5, and that's the absolute value of negative 35, which is 35, and that's not equal to 15. So that means let's see, 10. Where did I get that? Oh, well, that explains it. I copied the problem wrong. Or I copied the solution wrong. It's negative 5, not negative 15. But you notice by checking it, that's how I found my mistake. So this actually worked out kind of well. That was just a little bookkeeping error on my part. But it's really easy to do. So, I was testing you guys, and I'm sure you see the point now. Right? Okay, let's check negative 5 now. Because clearly negative 15 was not a solution. Let me get that off of here. At least you get to see what it looks like when it doesn't work. Okay, so let's check negative 5. So this time it would be 2 times negative 5 minus 5. That gives me negative 10 minus 5. Eesh. And I'm still taking that absolute value, so it's the absolute value of negative 15, which is 15, and that's a check. Right, but that could have just as easily been a computational error too. So we want to make sure we check our answers, because you never know when one of those little guys is going to sneak in there. I would have gotten this problem wrong if I had just done it that way. So let's look at the next one. Okay, so the next example here, and we're going to do the same thing we did this last time. Once I write it down, I want you to go ahead and pause and see if you can solve this one on your own. So let's do, let's do that. Yeah, let's do 2/5 x minus 2 is equal to 6. Let's just see how we do with that. So let's go ahead and pause and see what happens. Okay, so I'm assuming you have attempted it now. So again, just because there's a fraction in it doesn't actually change anything. It's still the same premise. We use the properties of absolute value to split into two equations. And then we use our knowledge of solving equations to solve those two equations. Both of those equations are types of equations we've seen before. So this ends up being the two equations, 2/5 x minus 2 equals 6. And the other one is 2/5 x minus 2 is equal to negative 6. And that's an OR statement, technically. And so we just go on solving these like we normally do. Remember our trick, we can multiply everyone by the common denominator, which would be 5. So that cancels here. That gives me 2x minus 10 is equal to 30. If I go ahead and add 10 to the other side, that gives me 2x is equal to 40. And then divide by 2, I get that x is equal to 20. So that's what happens over here for this side when it's equal to positive 6. Let's see what happens with negative 6 now. Turns out it's the exact same steps you would take with the other equation. Oops. So the 5's still cancel, and I'm left with 2x minus 10 is equal to negative 30 this time. And so if I add 10 over, that gives me 2x is equal to negative 20. And dividing by 2 would give me x is equal to negative 10. And so we have the two answers, x is equal to negative 10 and 20. A common question I get is, do these have to be written in a particular order? Well, I'll tell you this. There really isn't a particular order, right? If you wrote 20, then negative 10, that's fine. If you write negative 10, then 20, that's fine as well. Typically in, like when you're looking up an answer key and things like that, and you're checking your answer, they always list the answers from smallest to biggest. So if you were looking this up, like in the back of the book, they would list it negative 10 first and then 20 because negative 10 is smaller. But there's no law that says you have to do that. That's just how people tend to do it. You know, mathematicians like to impose order on things. It just makes things nicer and everybody's happier if things are in order. So, you know. Okay. So let's go ahead and look at another one here. So let's say I have the absolute value of 4/3 x minus 2 is equal to 1/2. Now, let's see what you can do with this one. Again, all the rules are the same. You still split the absolute value the same way, and then you just use your knowledge of solving equations that don't have absolute values to finish up the two equations. So go ahead and pause here and see what you can do. Okay, so I'm assuming you've paused it. So just like before, this is going to split. So I'm going to have 4/3 x minus 2 is equal to positive 1/2, or 4/3 x minus 2 is equal to negative 1/2. Right, so those are our two positions here, our two equations. Just make that look more equation-y. All right, so I know if I was approaching this, the first thing I would do is want to clear those fractions. And so I'm going to do that. So both equations have the same common denominator, so they're going to use the same number to clear the fractions. I have a 3 as a denominator here and a 2 here, so my common denominator is 6. And so everyone's going to get hit with a 6. So that's going to cancel, make that a 2. So this ends up being 8x. 6 times 2 is just 12. And then 1/2 of 6 is 3. Okay, so now I have a nice linear equation with all whole numbers in it. So if I add 12 over, that gives me 8x is equal to 15, and so x is equal to 15/8. Now, I've had this discussion with a couple of you. There's always this resistance when you have an improper fraction, feeling like it's not actually reduced because you haven't switched it to a mixed number. No, this is reduced. They do not have any common factors whatsoever. And there's nothing wrong with an improper fraction. It's actually one of the most unfortunate names in math because there's nothing improper about an improper fraction. It's literally just an unfortunate name. Sometimes it is nice to know that this would be 1 7/8, right? But there's there's no reason you have to write it like that. There's no law. Fractions are your friends. It's okay. Okay, now, so that's our first answer. Now we have to try out the same thing over here. So we're going to go ahead and multiply everyone by 6 again. What's nice is what works, whatever you multiply the first equation by, you're going to be multiplying the second equation by the same number. So again, this cancels to give me a 2 here, so that makes 8x minus 12. And this is now negative 3 because we're multiplying by negative 1/2. Okay, so now we just solve. So if I add 12 over, that's going to give me 8x is equal to 9. And then dividing by 8 gives me x is equal to 9/8. And so those are our two solutions, 15/8 and 9/8. Let's make that 9 look like a 9. Right, so we got our two equations. And neither one of them reduced, so we're done. Right, neither one of the fractions reduced, that is. Okay, good. Okay, so let's go ahead and take a look at the last one here. Is it the last one? No, it's not the last one. Never mind. Well, this is probably the penultimate example. Penultimate is the fancy word for second to last. Okay. Yeah, so let's take a look at something like this. Oh, let's actually take a look at something like this. Hang on. Let's take the absolute value of x minus 5 plus 8 equals 10. Okay, now you notice this is a slightly different format than the other examples. The big difference is this plus 8 here, right? There's no plus 8 anywhere else. And remember what our rule was, is that you had to have the absolute value by itself before you split into two equations. I can tell you what's going to happen if you try to split it right now before you alter anything. If you split it right now, one of your answers will be correct and one of your answers will not be correct. So what you want to do is move this 8 over to the other side before you split it, because otherwise you won't get the correct answer. So if I subtract 8, that changes my equation to x minus 5 is equal to 2, and now we're back in the form we had before. So we've reduced a more complicated problem into a problem we know how to solve. And that's really what we've been doing all along. Once we figured out that the absolute value forms two equations, right, that's the step that turns it into a problem we already know how to solve. And that problem we already know how to solve is how to solve linear equations. So we've taken an absolute value equation and turned it into two linear equations we do know how to solve. Right? Same thing here. So just by moving the 8 over and getting that 2, now we're back into a position where we know what to do with this. We split it. If I add 5 over, I get x is equal to 7. And here, if I add 5 over, I get x is equal to 3. Right? It just works that quickly. But it's knowing that you have to move this guy over to this side. Right? You're going to have to subtract that 8 over to be able to actually do this. Yeah. Okay, so let's look at one more here. Oops, that was the wrong button. What I hit. I'm having issues today. Okay, there we go. Now, so having seen that, let's take a look at this, because this is one of the things you have to watch out for. So let's say I have 7x minus 3 plus 10 is equal to 4. Okay, so let's go ahead and follow through here and see what happens. In fact, why don't you guys try this one? Go ahead and pause it right here and see what you get. Okay, so I'm assuming you've paused. Now this one actually pulls from something I talked about at the beginning of this lecture. So let's take a look at what we got here. So we'll go through the whole solution. If I subtract 10 from both sides here, I get the absolute value of 7x plus 3 is equal to negative 6. If I split this, and solve these things, let's see here. If I subtract 3, I get 7x is equal to negative 9, which gives me x is equal to negative 9/7. And then over here, if I subtract 3, I get 7x is equal to 3, which gives me x is equal to 3/7. Okay, and we go to check these answers. Now, here's what's nice about checking these. You notice they're sevenths, and I'm multiplying by 7. That kills the fraction in the first step. So if I'm checking this, the absolute value of 7 times, let's do negative 9/7. Minus 3 plus 10, and we want that to be equal to 4 if we plug that in. So these guys cancel, and I get the absolute value of, let's see here, negative 9 minus 3, and then I'm adding that to 10, and that gives me the absolute value of negative 12 plus 10. That means 12 plus 10. That's 22. It's supposed to be 4. So we ask ourselves, well, what went wrong here? What did I do wrong? Well, some of you may have spotted this already, but we were actually done with this problem once we wrote this step, because we have an absolute value equal to a negative number. Absolute values cannot be equal to a negative number. As soon as you get in your computation a point where you have an absolute value of something equal to a negative, automatically no solution. There's actually nothing else to do there. And it feels like you should be doing something more, but it's just a matter of being able to spot it. And it's going to catch some of you because you start getting into this pattern. You start getting used to working through the problems and doing the same thing each time, and you get to something that you have to notice that negative and you miss it because you're not looking for it. So this is probably one of the bigger areas where people miss stuff, is just not noticing that it's equal to a negative. So that's your warning there. Okay. So, well, I think that was a positive lecture. And there we go. Now, so we're going to go ahead and finish this. We're not done with absolute values or anything like that. We still have more absolute value stuff to do, but we're not going to cover it in this lecture. And so I will see you guys next time. And so until then, keep your pencils and your wits sharp.